Hello everyone. So today's topic is binomial theorem. So this topic is based on the concept of counting principle and permutation and combination. This topic is permutation and combination. So before proceeding to binomial theorem, you should have some idea about permutation and combination and fundamental principle of counting. So what is fundamental principle of counting? What is fundamental principle of counting? So if an event can occur in m different ways, if an event can occur in m different ways, following which another event can occur in n different ways. Following which another event can occur in n different ways. Then the total number of occurrence, the total number of occurrence of the event in the given order is given as equal to m into n. For example, there are three pens. There are three pens P1, P2 and P3. So here we can say m equal to 3, and if there are two shirts, there are two shirts S1 and S2, then we can say n equal to 2. So pens can be, therefore pens can be chosen in three ways and shirts can be chosen in two ways. Can be chosen in two way. Therefore we can say for every choice, we can say for every choice of a pen, there are two choices. Of shirt. Therefore there are 3 cross 2 is equal to 6 pair of pant and shirt are possible. Pants and shirts are possible. So next, so this was about fundamental principle of counting. So next is, what is factorial? What is factorial? So let's say there are x items, x different objects, or we can say items, which are to be arranged in certain ways. Then the total number of ways possible to arrange x items, the total number of ways possible to arrange x items is given by x factorial, where x factorial is equal to x into x minus 1 into x minus 2 into x minus 3 into x minus 4, and it will goes on till 1. So this is how we write factorial of any number. For example, let's say a word number. So therefore, how many arrangement of letters are possible to make a 6-letter word with or without meaning? How many ways we can arrange each letter of the word number? So since there are 6 letters, therefore we can say x equal to 6. So there are 6 factorial ways to arrange the letters of the word number, which is given by 6 factorial is equal to 6 into 6 minus 1 cross 6 minus 2 cross 6 minus 3 cross 6 minus 4 cross 6 minus 5 and 1 into 1. So we get 6 into 5 into 4 into 3 into 2 into 1. So we get 720 ways. So there are 720 ways to arrange the letter of the word number. So there are 720 ways to arrange the word number with or without meaning. So this was about factorial. Next is, what is the value of 0 factorial. So the value of 0 factorial is equal to 1. Next, permutation. So what is permutation? It is defined as ways in which number of objects can be ordered. Number of objects can be arranged. So we can also say it is an arrangement in a definite order of a number of objects taken some or all at a time. So mathematically, the number of permutations of n different items, number of permutations of n different items taken r at a time is given by NPR, where NPR is equal to n factorial divided by n minus r factorial. For example, there is a word number and we have to make three-letter word then number of ways it can be done is as follows. Then number of ways it can be done is as follows. So from here we notice that word number has 6 letters, that is 1 2 3 4 5 6. Therefore we can say n equal to 6. So this is first, and we have to make three-letter word from the letters of the word number. So, or we can say there are three vacant places to be filled by letters. of the word number. So therefore we can say R is equal to 3. So number of ways in which we can form a three-letter word is number of ways is equal to NPR, which is equal to 6P3. So 6 factorial divided by 6 minus 3 factorial is equal to 6 cross 5 cross 4 cross 3 cross 2 cross 1 divided by 3 cross 2 cross 1. So 3 cross 2 cross 1 will cancel out and we get 120 ways. So number of ways in which a three-letter word can be formed is 120 ways. So in permutation, order is important. Order is important. That is, every order is unique. For example, in previous example, we have a word number, and if we form a three-letter word from the letters NUM, then there are 3 factorial ways to arrange NUM. That is NUM, NMU, and UNM, UMN, MNU, and MUN. So these are 3 factorial ways to arrange NUM, that is 6 number of ways, and each order is unique. That is, we cannot say that NUM is not equal to NMU, is not equal to UNM, is not equal to UMN, is not equal to. So every order is unique. Therefore every word is unique. Hence in permutation order is important. Next is, what is combination? So definition is same as permutation. Definition is same as permutation, but here order is not important. Therefore mathematically NCR is equal to NPR divided by R factorial. So if we take the example of previous example, we have n equal to 6 and r equal to 3. So if we find the combination of these n and r, then we find that 6p3 divided by 3 factorial is equal to 120 divided by 6, which is 20 ways. So we can see the number of ways drastically reduced from 120 ways to 20 ways. So we can see by using combination. The number of ways drastically reduced from 120 ways to 20 ways. 120 ways to 20 ways. This is because in combination order is not important. In combination order is not important because we only care about the selection and do not care about whether it makes sense. We only care about selection and do not care about whether it makes sense. For example, in previous example, if we take NUM as three-letter word, so there will be, according to combination, there will be only one way of representing this word. Rest all the other ways are same as NUM. Rest all the other ways are same as NUM. That is NUM is equal to NMU is equal to UNM is equal to UMN is equal to MNU is equal to MUN. Therefore, in combination, selection is more important than arrangement of individual elements of any particular order. In combination, selection of order is important. Irrespective of the order of individual element of that order. So to avoid also, therefore to avoid redundancy in arrangement, combination is used where meaning is not important. So this was about fundamental principle of counting, permutation and combination. Next is binomial theorem. So whenever there is a expression like whenever there is a expression like a plus b to the power n, where n is equal to index or power of a plus b. Then to expand this expression there are three methods. Then to expand this expression there are three methods. First is repeated multiplication. Second is Pascal's triangle. Third is binomial expansion. So first we will look at repeated multiplication. So first is repeated multiplication. So what is it means that each expression is multiplied n times. It means each expression is multiplied n number of times, n times. So if a plus b to the power square, and where n is equal to 2, therefore we write it as follows: a plus b cross a plus b. So it is multiplied two times. So we will do the normal multiplication of each term: a square plus ab plus ba plus b square. So a plus b square we get a square plus 2ab plus b square. Likewise, for a plus b whole cube, where n is equal to 3, we multiply this a plus b three times: a plus b, a plus b, and a plus b. For a plus b 4, where n is equal to 4, we multiply this expression four times: a plus b, a plus b, a plus b, and a plus b. Similarly, this goes indefinitely if we increase the power of n. So likewise, we can find any power of any expression. We can find power of any expansion, but it will be time consuming. Therefore there is another method which is called Pascal's triangle. So it is a structure like a triangle. It is a structure like a triangle with one at top vertex and running down the two slanting side. Therefore, if we have a plus b where power is 0, that is n is equal to 0, and we have this coefficients or triangle of coefficients. So we get 1 at the top, and if we have a plus b to the power 1 where n is equal to 1, we get a slant 1 at the slanting side on both sides. So this is slant side and this is also slant side, and this is vertex. So if we have a plus b whole square, we have n is equal to 2. So again we add 1 here and 1 here. So if we have a plus b whole cube where n is equal to 3, we add 1 and 1. So how to fill up these vacant spaces? So for n equal to 1, we put a triangle here, and for n equal to 2, we add these two terms and write 2 here and put a triangle between the gap of 2 and 1. Similarly, we put a triangle after 1 and then add 1 and 2, we get 3, and we put a triangle below the 2 and then we add 2 plus 1 and we get 3 and then put a triangle. So again for n equal to 4, we put a 1 here and 1 here, then after 1 we put a triangle, then add 1 and 3, 4, then again triangle, then 3 plus 3 6, then again triangle, then 3 plus 1 4. So this is how if Pascal's triangles look like, where each number in Pascal's triangle is a coefficient of expansion of a plus b to the power n. So for example, a plus b whole square. So we know a square plus b square plus 2ab. Therefore from triangle we can also prove, from Pascal triangle we can also prove that a plus b whole square is equal to a square plus 2ab plus b square. So if we look at a triangle, then at n equal to 2 we have values of coefficient like 1, 2 and 1. So this is starting point and this is end point. So we start with 1 and multiply with a square plus 2 into ab, and plus we end with 1 into b square. So we get a square plus 2ab plus b square. So this is how we can get expansion of any expression about n. But how to decide which coefficient is attached with which term? How to decide which coefficient is attached with which term? That is, if you have a triangle, that is this is a triangle 1 1 1 1, so this is a triangle 2 and triangle 1, triangle 3, triangle 3, triangle 1 1, triangle 4, triangle 6, triangle 4, triangle 1. So this will go indefinitely up to infinity. So if we have a triangle, we will always start with from left hand point, or we always start with left end point. That is, this is left side and this is right side, and this is left end point and this is right end point. So if we have n is equal to 2, then our matrix numbers will look like 1 triangle 2 triangle 1. So this is left side and this is right side. So we start with left side, where 1 is a starting point, 1 is a starting point, and on the right side 1 is a end point. Second, when we start, when we use a plus b to the power n, then we will start with highest power of a and lowest power of b, and we will end with highest power of b and lowest power of a. So what are highest and lowest power? So highest power is n and lowest power is 0. That is, if we have n equal to 2, then according to Pascal's triangle, we get 1, 2, 1 as our coefficients. So 1 is a starting point, start, and on the right side 1 is the end point. So we write it as follows. We multiply the starting point 1 into highest power of a, which is 2, and b will be at lowest power, plus 2 cross a 2 minus 1, and b will be 0 plus 1, plus 1 cross a 2 minus 2, and b 0 plus 2. So at the end point we get highest power of b and lowest power of a, 0 and 2. So third point is, when we expand a plus b, then power of a decreases by 1, power of a decreases by 1, and power of b increases by 1. As we can see in this expression, 1 cross a square cross b 0 plus 2 cross a to the power 1 and b to the power 1, and 1 cross a to the power 0 and b to the power. So we can see a has the highest power at the starting point, then it decreases by 1, and at the end point it has the lowest power. So power of a is decreasing by 1. And for b has the lowest power at the starting point, and then it increases by plus 1, it increases by plus 1, and then at the end point it has the highest power, which is 2. So this is how we write expansion of any term a plus b to the power n by Pascal's triangle. Next, if let's take another example, a plus b to the power cube. So here n is equal to 3. So from triangle we have the coefficients as 1 triangle 3 triangle 3 triangle 1. So this is a starting point, this is end point, and we know power of a is maximum at starting, and at end point power of b is maximum. And here power of a will decrease by 1 in each step, and power of b power of b will increase by 1 in each step. So we write it as follows: 1 cross a to the power n to the power into b into 0 plus 3 cross a n minus 1 cross b 0 plus 1 plus 3 into a n minus 2 into b 0 plus 2 plus 1 into a n minus 3 into b 0 plus 3. So we put n equal to 3 here. So 1 cross a cube plus 3a square b plus 3a b square plus b cube. Therefore a cube plus 3a square b plus 3ab square plus b cube. So this is expansion of a plus b to the power n when n is equal to 3 by Pascal triangle. But there is a limitation to this expansion method. After some power of n, after some power of n, Pascal triangle become time consuming. Pascal triangle become very large and time consuming. Therefore, there is a better method than Pascal's triangle, which is called binomial expansion. So binomial expansion is given by a plus b to the power n, where nc naught plus an plus nc1 plus cross an minus 1 b plus nc naught nc2 an minus 2 cross b2 dash 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 ncn and b to the power n. So this is n. So this is a binomial expansion. So we can say from principle of mathematical induction, it has been proved that pk plus 1 is true whenever pk is true. Therefore, a plus 1 is true for every positive integer. Where C is a symbol of combination. Where we know combination is given by NCR is n factorial divided by r factorial and n minus r factorial, or NPR divided by r factorial. where P is permutation and C is combination. So let's take an example. 98 to the power 5. So we can write it as 100 minus 2 to the power 5. So here A is equal to 100 and B is equal to minus 2 and N equal to 5. So applying binomial expansion, we get 5C naught A to the power 5 and minus 2 to the power 0 plus 5C1 100 4 and minus 2 to the power 1 plus 5C2 100 to the power 3 and minus 2 to the power 2 plus 5C3 100 to the power 2 minus 2 to the power 3 plus 5C4 100 to the power 1 and minus 2 to the power 4 and last 5C5 100 to the power 0 and minus 2 to the power 5. So after expanding this we get 93039207968 is the answer to this expansion. So there are some important points before using binomial expansion. Some important points. Before using binomial expansion, first point is a plus b to the power n to the power n, where which is equal to k equal to 0, which goes till n, and n c k into a cross n minus k into bk, where this symbol is known as summation. Second point is nck are binomial coefficients. Like we discussed in Pascal's triangle, the coefficients mentioned there were in the form of nck. So in Pascal's triangle, the coefficients we have are equal to nck. Third point, there are n plus 1 terms in the expansion of a plus b to the power n. There are n plus 1 terms in expansion of a plus b to the power n, that is there is one more term than the index n. There is one more term than the index n. For example, if we take n is equal to 2, therefore a plus b whole square is equal to a square plus 2ab plus b square. So we can see when index is 2, we have after expansion we got 3 terms, 1 2 and 3. Fourth point is in the expansion a goes on decreasing and b goes on increasing. That is, power of a goes on decreasing and power of b goes on increasing. Fifth, last point, in the expansion of a plus b to the power n, in the expansion of a plus b to the power n, the sum of indices of a and b is always equal to 1, always equal to n. For example, a plus b to the power n. So we get nc naught a n b naught plus nc1 a n minus 1 b1 plus nc square a n minus 2 b2. So if we look at the expansion of ab and we add the powers of ab like an and b naught. So if we add the powers of a and b, we get n. This is the first term. In second term, an minus 1 and b1. So if we add the powers n minus 1 plus 1 is equal to n. Like in third term, an minus 2 and b2, we get n minus 2 plus 2 is equal to n. So in every term of expansion, the power of a and b is equal to n. So this was about binomial expansion. So y combination is not used. Y combination is used, not permutation. Y combination is used, but not expansion, not permutation. Not permutation. So Y combination is not is used, but not permutation. So let's take a plus b to the power 3 and we expand this by permutation. Therefore we get 3p naught a cube p naught plus 3p1 a square p1 plus 3p2 a1 b square plus 3p3 and b cube. So after expansion through permutation, we get a cube plus 3a square b plus 6ab square plus b cube, and by normal repeated multiplication we get a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. So therefore we get, by permutation we get one extra term. Therefore by permutation by permutation we get one extra term, that is 3ab square, which is trying to exaggerate the solution, which is trying to exaggerate the solution. And as we go on increasing, and as we go on increasing the power of index, power of a plus b. This redundancy will increase up to greater extent, and it will cause an error of multiple counting. It will cause an error of multiple counting. So therefore to avoid redundancy, combination is used. So next is, what is general term and middle term? So what is general term? We know that there are n plus 1 terms in the expansion of a plus b to the power n. So therefore r plus 1th term, therefore we can say r plus 1th term will be n c r a n minus r b r, which is also called general term, which is also called general term, and is denoted by t r plus 1. Therefore mathematically we can write t r plus 1 is equal to n c r a n minus r and b r. So this is a general term. Next is, what is middle term? What is middle term? First, if n is even, then n plus 1 will be odd. Therefore in the expansion of even power we have odd number of terms, therefore middle term will be bracket n plus 1 plus 1 divided by 2. 2th term will be middle term. And second, if n is odd, then n plus 1 will be even. So there will be even terms. So there will be even number of terms. So when the terms are even, then we have two middle terms. There will be two middle terms. When n is odd, therefore n plus 1 by 2 and n plus 1 by 2 plus 1. So these are the two middle terms when n is odd. So let's take an example to find the middle term. Example 2x minus 7 and to the power 7. So here n is equal to 7 is equal to odd. So there will be n plus 1 is equal to 8. 8 terms in the expansion. Therefore number of terms are even. Number of terms are even. So there will be two middle terms. There will be two middle terms. That is 7 plus 1 by 2. That is fourth term, and 7 plus 1 by 2 plus 1. That is fifth term. So there are two middle terms, fourth and fifth term. Second, when power is even, 2x minus 7, 6. So here n is equal to 6, which is even. So number of terms will be odd. Number of terms will be odd. That is n plus 1 is equal to 7. So there will be only one middle term, that is given by n plus 1 plus 1 by 2, which implies 8 plus 1 by 6 plus 1 by 2. So we get 6 plus 2 is equal to 8 by 2 is equal to 4. Therefore we get fourth term as the middle term. Next, last example, find a where a is any constant if the 17th and 18th term of the expression two plus a to the power 50 are equal. So we know the general. So we know that general term is given by r plus 1. So we have r plus 1 is equal to 17 and r plus 1 is equal to 18. So we can say here r is 16 and here r is 17. So by general term tr plus 1, where tr plus 1 is equal to ncr and a to the power n minus r and b to the power r. So this is first and this is second. So from first, r is 16. So we get t17 is equal to 50 c16, where a is equal to 2, 50 minus 16, and second number is a, and from second we get r is equal to 17, where t18 is equal to 50 c17, 2 to the power 50 minus 17 and a to the power 17. So this is first equation, this is second equation, and here a is equal to 2 and b is equal to a and n is equal to 50. So from question we have t17 is equal to t18. So 50 c16, 2 to the power 50 minus 16 and a to the power 16 is equal to 50 c17, 2 to the power 50 minus 17 and a to the power 17. So from here we get 50 factorial divided by 16 factorial, and 50 minus 16 is 34 factorial into, if we take the 2 term on the left side, we get 2 50 minus 16 divided by 2 50 minus 17, and is equal to, we take a to the right side, a to the power 17 and a to the power 16. So from here we cancel out a, and from here we cancel out 2, and we also have 50 factorial divided by 17 factorial and 50 minus 17 factorial. So this will cancel out. So we have 2 to the power 1 divided by 16 factorial and 34 factorial is equal to 1 by 17 factorial into 33 factorial multiplied by a. So we can also write 2 divided by 16 factorial and 34 into 33 factorial is equal to a by 17 cross 16 factorial into 33 factorial. So from here 16 cancel out and 33 cancel out, and we get 2 into 17 is divided by 34 is equal to a. 17 times 2 is 34 and 2 times 1 is 2, so we get a is equal to 1. So this was about binomial expansion using counting principles, permutation and combination, and some properties of binomial expansion. So thank you.